Lesson 16.1. I'm going to take a few minutes to go over some extra examples just to make sure that you are clear, as this is an important standard. All right, so to simplify each expression, we have been combining like terms as we went through the task. And the first thing I have showed you to do is anytime that you have a negative in front of the parentheses is go ahead and distribute that negative. And that way you get rid of that. So I'm going to have 2xy plus 9 come down. And then I'm going to have negative times x squared, which is negative x squared. I'm going to have negative times negative xy. A negative negative makes that a plus xy. And then a negative negative 3 makes that a plus 3. Now, once you distribute the negative, all my signs are exactly what they are. So now I can just combine like terms. So I have an xy and I have another xy. So I've got 2 plus 1, which is 3xy. And then I've got a negative x squared. I'm going to put it in the front because actually that's my largest exponent there, if I'm putting it in standard form, which I tend to try to do. And then I have plus 9 and plus 3, which is just 12. All right, so this would be my simplified expression for the first problem there. All right, so moving on to number 2, I've got an x squared y. I've got an x squared xy, so nothing will combine with this term, so I'm going to bring it down. X squared y. And as you can see, this has a plus, so I don't have to even worry about the parentheses. In this case, when I'm adding to expressions, the parentheses are just extra information. It's grouping these together, but you don't have anything to worry about with the plus because your signs will not change. All right, so I got rid of this one. Now I've got a 3x squared, so I'm going to do 3x squared. And then I have an xy and an xy. So I've got positive 2 minus 1. So 2 minus 1 is just 1 xy. And then plus 3. And that's it. So I'm just combining like terms. They have to have the same variable, same exponents to combine like terms. All right, a few more examples here. So for this example, again, we're adding. So the parentheses is just kind of extra information. So I'm going to combine my x squared and my negative x squared. So I've got 3 minus 1. So I've got 2x squared. And then I've got 3x minus 1x. So 3 minus 1, again, is 2x. And then I have 3 plus 4, which is 7. So this is my simplified expression here. All right, again, we're adding. So the parentheses are extra information. So I've got 8x squared and 1x squared. 8 plus 1 is 9x squared. And I have an xy and an xy. So if I've got 8xy plus 4xy, that gives me 12xy. And then I have 3 plus 12, which is 15. All right, for the next one, I have a negative. So I'm subtracting this expression from this expression. So when I subtract the whole expression, the first thing I have to do is distribute that negative to each term. So I'm going to have y squared plus x plus 3 will come down exactly as it is because there's no negative in front of it. And then this one will have a negative 4y squared. This will have a negative 5x. And then a negative 2. Again, I don't need parentheses. Once I distribute that negative, get rid of the negative, and then I'm just going to combine like terms. So I have y squared and a negative 4y squared. So I'm going to have negative 3y squared. And then I have 1x minus 5x. So 1x minus 5x would be negative 4x. And then I've got 3 minus 2. 3 minus 2 is 1. All right, for this one, again, I'm going to distribute the negative. So I'm going to have a squared minus 2b plus 3. And then I'm going to have a negative a squared minus 2b. So if I have a positive a squared and a negative a squared, those cancel. and I have a negative 2b and another negative 2b, so negative 2 and negative 2 is negative 4b, and then plus 3. So my a squared's canceled, and that means my 4b, my negative 4b, was my leading term. All right, if we want to review, this would be a quadratic. This was a 1, 2, 3 term, so this is a trinomial of degree 2. This is a trinomial of degree 2 as well, because it's 1, 2, 3 terms. This is a linear binomial because it's 2 terms, and the highest degree is a 1. So just kind of reviewing our terminology a little bit. All right, let's look at one more problem. The figure at the right represents a mailbox where x represents the radius of the half cylinder and all other measurements are in terms of x. What polynomial models the volume of the composite figure? All right, so you can see the top half of the mailbox is a half of a cylinder. And then the bottom here is a rectangular shape. And we know that the volume for this part is going to be volume equals length times width, times height. And the volume for a cylinder is pi r squared h, but because we only have half a cylinder, we're just going to do half of that. So we got the volume, we'll call it volume 1 up here, and then volume 2 is the rectangular shape down here. All right, so let's look at what we have. So if we start with the top, the half of the cylinder, let's start with just what a cylinder is. So we're going to have pi r squared h and if we look at what we're given, r is x, so we can plug in x for the r here, and it's r squared, so x squared, and then h is the height, but the height is this distance here. Okay, and we see that that is 2x plus 12. All right, so we can go ahead and distribute that. So this term can be distributed to each one of these terms. So I'm going to have 2 pi x squared times x to the first, same base, you add exponents, so it's going to be x to the third, and then plus 12 pi x squared. Now, that's the volume of a cylinder. We need half of that because the top of this mailbox is only half of that. So let's erase this, and I'm going to put half of that. So half of that's easy. Half of 2 is 1, so we're going to have pi x cubed. Half of 12 is 6. All right, now this represents the half of the cylinder, which is the top of the mailbox. All right, so now let's look at volume 2, which is the length times width times height of the base of the mailbox. So we're going to have 2x. We're going to have 2x plus 12. And we're going to have 2x minus 1. All right, so multiplication is commutative and associative, so I'm going to multiply these two binomials first. So I'm just going to bring down my 2x so I can multiply the two larger terms first. So I'm going to have 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. 12 times 2 is 24x. And then 12 times negative 1 is negative 12. All right, now I can combine these like terms here. So I'm still bringing down my 2x. I've got 4x squared. The only thing I'm going to do this time is combine my x's. So I've got negative 2 plus 24. So that's 22x minus 12. All right, now I have to distribute the 2x to everything. So it's going to be 8x cubed. I'm going to have 44x squared. And I'm going to have negative 24x. All right, and so that is my volume 2. Now, to find the volume of the whole mailbox, I have to add this and this together. Okay, so I can see that I have some like terms. I have an x to the third and an x to the third, and I have an x squared and I have an x squared. So let's add these two terms together. So if I do V1, volume 1 plus volume 2, that means I'm going to have pi x cubed plus 6 pi x squared plus 8x cubed plus 44x squared minus 24x. And this is a 44. All right, now we already noticed that these both have x cubed, so I'm going to combine my pi and my 8. So how do I combine a pi and an 8? I'm just going to write it as 8 plus pi times x cubed. All right, and then I've got an x squared and another x squared, so I've got x squared here and x squared here. So I'm going to have 6 pi plus 44 x squared, and then bring down my minus 24x. So this represents the volume of the mailbox. It's not very pretty, but if you know what x is, you could simplify this quite a bit. We know that pi is just a number, but in this case, in a lot of cases, we just leave it in terms of pi. So that's all for the extra examples. If you have any questions on lesson 16.1, please ask.